Okay, so the first one here, I've got a right angle triangle. So as soon as I see that, I'm thinking of what words? Sokotoa, okay? So to do Sokotoa, I need to start labeling up that triangle. If you've got your test with you, you should be having a different colour pen ideally in your hand now and putting in any marks that you've got. Go, yeah, did that. You should be feeling really pleased with yourself if you've done that. And if you haven't, then you put in the correction now, okay? So that's the angle. So this must be the opposite. This must be the hypotenuse. By process of elimination, this one must be the adjacent. I'm given the hypotenuse. They want me to find out the length of the side MN. So MN goes from M to N. It's the adjacent. So we're looking at using K. If you said anywhere, this is going to be a cos angle. So cos, I could go straight to cos 27 equals the adjacent. So that's MN maybe. You could call it adj if you want to. Divided by the hypotenuse. That would be worth 2 marks, that statement there, okay? So if you've got it, 2 marks. You've got 1 if you tell me it's cos. All good so far? You give yourself the marks if you've got your test in front of you. How do I get that third and final mark? You can see it's worth 3 up here. How do I get that third and final mark? Ben? Excellent, yeah. So 13.5 is currently dividing the MN. I don't want that anymore. I can just literally put no time sign in my calculator as well. And it knows that. It knows that touching means timesing. So 27 goes in there. Press equals, and I get that answer there. Can you see that? So 13.5 cos 27 is equal to... Now, here's an interesting one. I've just said 12, and then I put point. I'm like, oh, it's sort of 0.0. Can I write that? Of course you can. You can round to 0.0. It's much easier for you, and that'd be centimetres, because it's obviously side. And just say that you've rounded to 1 decimal place, but say it's 11.99, still rounded to 12.0, but you just need to say, look, I've rounded to 1 decimal place, so I don't want to say rounded to the nearest whole number. So that's how you got the third mark there, okay? That would have been worth 3 marks. Technically speaking, I hate telling you guys this. If you write 12.0, I can see you've used that formula, I can give you the full marks, but show me your thinking. Conrad? Yes, it says MN, and that's side I found. All good? Don't worry, I'm free to ask and sit there and think, oh, I'm not sure if he's right there, okay? Ask, okay? So I'm going to mute the audio on this anyway, so it doesn't matter anyway. Okay, so the next one, let me just move the camera a little bit closer because it was only a half page here. Okay, so this is all about your visualization here. It says, please can you go and work out AG? Can anyone sort of give me an analogy of what AG would look like maybe in this classroom? Ben?
It would just be
Yeah, and I brought in my laser measure, didn't I, to sort of show you what it's talking about, just to try and get your head around what this looks like. That's what's going on here. We're going from that pipe there to this pipe down here and working out what that length is, okay? So to do that, I need to visualize the right angle triangles in here. Now, obviously, this one here, I know that's 5, and then if I knew this one here, which is my green one, just going along the flat bottom of that, then I've got a right angle triangle sort of standing up within that cuboid. The problem is I don't know that green line that I've just drawn. However, I can work it out because, again, thinking of your perspective, I've got 7 squared plus 3 squared would tell me what that side is squared, okay? So what I'm looking for to get the marks here is to say, and we'll call that EG, okay? Not because it's an example, but because that's the letter at the start and the end, okay? So I'm going to say 7 squared plus 3 squared equals EG squared. If you've worked out to do Pythagoras, if you see that in any way, shape or form, I can give you a mark straight away. Nowhere is it telling you to use Pythagoras' theorem. You've got to realise to do that, okay? Did you want some paper, Connor? Because I can see Tom's doing some writing down, which is probably a good idea, in all honesty. If you're anything like me, I used to have a note-taking use. I'm dyslexic. I was like, this is awesome, and then I just realised I wasn't listening. I was just like, someone else is making notes for me. It's just like easier said than doing work. Oh, it's embarrassing. This is on video. I can't get the page now. I'll cut this bit. We got there in the end. Where there's a will, there's a way. Okay, that's it. No problem. Okay, so back to this question here. Sorry for the delay there. My fault. Now, you've got 2 ways of doing this, right? So the best way to do this is just literally stick into your calculator. 7 squared plus, was it 3 squared? And you're going to get root 58 eventually. But I would definitely go and make this statement here that you get 58 equals EG squared, and then root 58. I think this came up as a third question the other day, but I might be working with year 11 actually. I'm thinking that off the top of my head. Don't do anything to that. That's going to be more hassle it's worth. If I square root that answer, so I press square root ans, and then press SD. That's I don't want that number to deal with. That is nicer looking like that, isn't it? Not left to right. So we know that EG now is the square root of 58. So to go and find this one, this line here that I've highlighted is actually the hypotenuse of this right angle triangle that's standing up. So I know the 5 there. So let's use the other two sides here. I know that 5 there, and now I know that is root 58. I can just go and work that out. So I'm just going to put a line down my work here. So you would have got 2 marks if you got root 58. That's what I need to get to give you 2 of those 4 marks. Need to see root 58 somewhere. Okay. From here then, I want to do EG squared plus AE squared equals AG squared, which is what they wanted. Now, you'll notice I didn't actually go into quite that level of detail before. There is a reason why I've done it. What is the length of AE? A to E is 5, so that's 5 squared. Equals AG, I don't know what that is, so I'll leave that as AG squared. What's EG squared? Yeah, it's actually 58. We've actually got a definition for that. Okay, I could say it's root 58 squared. It is. Root 58 times by itself would cancel just being 58. But there's no reason why if you write it out or think of it like that, and I rarely get the opportunity to share that with you, you can just write 58 in there, okay? You can do, technically, okay? So from here, I can say 58 plus 5 squared is 83. 83 equals AG squared. Square root 83. Now this will give me a horrible number because I know it's not a squared number. So I square root that answer and get root 83. SD it and I get a horrible number. Do I want the root 83 or this horrible one? Why? It's the last answer, yes. Because it's the last answer, I want to be seeing 9.1. Oh, it did say to 2 decimal places. I always do it to 1 unless it states otherwise. It does state otherwise. It says it wants it to 2, so I've got to say it's 9.11 centimetres in brackets to 2 dp equals AG. 2 marks are getting that, 2 marks are getting that, okay? 1 mark again for substituting your answer into Pythagoras' theorem. This one here, again, I did try to give you some nice ones here. It's slightly different to the first trig one, but it's very similar. So from here, we've got a hypotenuse, we've got an opposite, and we've got an adjacent. We need to work out this angle F. I've got the opposite, I've got the hypotenuse, so even without writing SOHCAHTOA, I'm able to visualize that one. What am I going to use? Sine, yeah? Sine angle, so sine F equals the opposite side, 8.4, over the hypotenuse side, which is 12.3. Okay? Now, how do I go and find F? At the moment, it's got sine with it. I don't want it to have sine with it. I just want it by itself. Isaac? Good. We're going to get F equals sine minus 1 of 8.4 over 12.3. That's going into my calculator, okay? You got 1 mark for identifying it with sine. You got 1 mark for doing the sine minus 1. You'll get the 3rd mark for then actually working out the answer. Now, just watch what's going on here for a second, okay? I'm going to press equals now on my calculator. I get math error. And usually this is where students start falling apart and going, whoa, I can't do this, can't do this, can't do this. Let's just go back so we can see what I wrote. I think I've got a couple of people who think they've got it already. Go on, Ben. You can't, it's the hypotenuse is the biggest number. I've written down the correct numbers, but you see in my question there, I've got 8.4 over 12.3. I just accidentally wrote them in my calculator the wrong way round. People do that all the time, okay? People your age do that all the time. Adults do it all the time. And they go, math error. Oh, you've just done it the wrong way round, okay? So just chill out. Your calculator knows that has to be the bigger answer on the bottom. So that's all it's telling you, okay? So 12.3 goes in there, and then 8.4 goes up on the top. And I should get an answer this time, and I do 43.1 to 1 decimal place. So F equals 43.1 degrees to 1 decimal place. Okay? Or this one I chucked in, I probably could have got away without chucking it in, but can anyone think why I put it in? Conrad, I thought you might be able to tell me. It does. I thought this was a stinker of a question, this one. This is easily the hardest question so far. Tom? 43.1. I haven't done the clearest 3, to be fair. Yeah, 43.1. Okay. Okay, so the first thing I'm reading here is about greatest and possible in bold. So I'm just coming back into the statement here, and it says things are measured to the nearest millimetre. Now that's a pain in the backside in itself because they're both in centimetres. So this really was a horrible question. Ben?
Can you just go to 3.45 and then 2.55?
Good, that's exactly what you're going to do. To the nearest millimetre is to 0.1 centimetres. So then you're going to halve that, which is 0.05. And then you're going to take that off and add it on. I am going to confirm that, okay? Nearest millimetre means the nearest 1 millimetre. Because those are in centimetres, this needs to be in centimetres, so it would be a tenth of that. I should say centimetres. Whatever it's measured to the nearest, we always divide that by 2 to get half of the answer that we add on and take off, okay? So that's where Ben's got this 0.05 from. Now from here, we're then looking at the, we'll call it what, the base and the height. Height, base, lower bound, upper bound. Okay, Ben's already told me the height. He said it's 3.45 or 3.55. Anyone comfortable to explain how Ben got that? Who's not Ben? Go on, Conrad. Excellent. It's this answer here that's affected those ones there. So if you weren't sure where that's come from, that's where it's come from. Someone who's not Ben or Conrad, can you tell me what the base is going to be? Lydian?
Upper bound is
4.85, yeah.
and the lower bound is 4.75.
Excellent, yeah. Spot on, okay. Now, I've got absolutely no idea. Like, usually I'm able to say, look, use a bit of logic here. I've got no idea. However, when we've worked with upper bounds, lower bounds in the past, we've seen that there's some sort of like cross-diagonal working going on here. I would expect that's going to be the case here, okay? I was doing this with my year 11s the other day. Not this question, but something similar. They said, I thought to find the lowest bound, you'd be using the lowest of both. I was like, no. I've just done a massive piece of work with year 10 to make sure they're not falling for that. I was thinking they're a year ahead of you and they've got exams coming up for too long. It's a really important thing to know. So, as I said, on my gut feeling is I'll be dealing with cross diagonals, okay? I can go and check afterwards. So what I'm going to do now is just label them up. So this is the opposite, this is the adjacent. They're the ones I've got. So I'm going to be using tan. So I'm going to do here, just a line here. I'm going to do tan x, tan angle, is equal to, and then the opposite. So I'm going to choose the 3.45. What do you think I'm going to put it over? 4.85. I'm going to work diagonals. Just my gut feeling is that's going to be what's going to make the difference. And if you think about it, your base being as short as it is, and that being higher is going to adapt that angle, isn't it? Okay, but it's nowhere near as logical as some of the other stuff we've done. It's hard, this one. So 4.85 going in there. So to get the answer, I'm going to do tan minus 1 of that fraction, so 3.45 over 4.85. So let's work out what that is. 4.85. Now, just little hacks on your calculator. You don't have to put a bracket on the end of that. It saves you about 2 milliseconds. But when you're working through things like this, every now and again, you think, I just want to do this really quickly. So I've got one answer here. I don't know if it's the greatest or the least. So I'm going to say that's 35.43 degrees to 2 decimal places. How am I going to go and find the other one? What am I going to do instead? Yeah, literally do the inverse of what we just done. Nice word, Conrad. So that's going to be 3.55 there over 4.75 here. So then I'm going to do x equals tan to the minus 1 of that. Now, do we know a hack how to do this quickly on our calculator? Bear in mind, I've got the answer. You're using this replay button here. You come back and you delete the 8 to 7. Come up here and delete that to 5, okay? And don't press ands, just press equals. And we get a bigger answer, don't we? X equals 36.77. Okay, well, which is the biggest angle? Obviously, the one I just wrote. That was a particularly hard question. Did anyone beat me to that? Did you? Seriously well done. That's a really hard question. That's like one of the hardest questions we've done in anything. That's awesome. That's really good. So 36.77, 35.43. Okay, then over the page. Last one as well. Oh, thank goodness we're on the last one. Just come up a little bit. I chucked this in just because I know I've not covered the wording, but my gut feeling is like you lot are actually going to be fine at just taking the intuition on how to solve this, and it sort of helps you a little bit within the diagram. So it says Llynnos walks to the summit of Snowdon, passing the lake called Llyn Gaslyn. Her height above the sea increases by 485 metres from Llyn Gaslyn to the summit. From the summit, she sees two small boats on Llyn Gaslyn. If I have to say that word one more time, right, from the lake. Both boats are in the same direction from the summit. The angles of depression of the two boats are 41 and 27. Now, that's the word I thought you weren't going to like. Go on.
Is it like from 90 degrees?
Yeah, 90 degrees, so depression is looking down. Any idea what it might be called going up? I'll give you a clue. You stepping them in St. David's. Something said it then. Great shout. It's not an angle of happiness, because depression down, I see the link you're making, and I want that link to be made with depression, as in angle of depression. Okay? When you go up, you sometimes get in these things in a big building that's got loads of floors, a lift, and what's an American word for that? Elevator. It's called an angle of elevation. That from the 90, you're looking up. You're elevating your head. You're depressing your head means you're looking down. Does that make sense? I knew I hadn't covered that with you. My gut feeling was you'd work that out from the diagram anyway, so I thought it was quite a nice one to put in. Okay. Has anyone got a strategy to work out the distance between the two boats? Have you? Excellent, well done. Will B, what did you do?
So I worked out what the bottom line was just with this right angle triangle.
Okay, so what is this bottom line here then? What is that?
I got between the 65 and 90.
How? What did you do?
So I did 485 plus 49.
Excellent, that's what I was after, okay? So let me just clarify the thing I was looking for then as a maths teacher. I was looking to hear Will tell me 49 degrees. It's going back to that 90 degrees that you're looking down from. That is made an angle of 90 degrees. So 41 has come up to this first line here. So the rest of that has to be 49. So in this first triangle, Will's absolutely spot on to say this has got to be 49. That's the angle I know, so that's opposite, and this is the adjacent, okay? We're not working with the hypotenuse, so it means we're using tan. It's going to be tan 49 is equal to the opposite, which I don't know, over the adjacent, which is 485. So the opposite, you can round this because although it's not the final answer, it sort of is, okay? So we're going to have 485 times by tan 49, and that's going to give me 557.9 to one decimal place, and that would be in meters. Okay, agreed, Will?
I didn't get that, but
Are you happy with what I've done? Have I done something wrong? So I might have.
No, that's
Soccer toe yes, it should be. That's what you had as well. Cool. Well, Will, your strategy was correct, and that's the hard thing about this question. So well done. Hats off to you for that. How am I going to find out the base of this entire big one here? Go on, Ben.
Jake 41 from 90.
Okay.
Sorry, take 27 from 90.
Okay, even better. Yes, we did 90 take away 41 to find this one. Effectively, that's what we're doing here now, but it's obviously a different angle. So that's 27. So 27 take away 90, 63. 63. Yeah. So that's 63 degrees in that angle there. So what we're going to do is actually find all of this base this time, okay? So when we're working with the 63, we're going to find the entire length of that, okay? It's hard to spot that 63. This is where this is a challenging question. So this is tan 63 equals the opposite side. Don't know what that is. It's still the opposite. Over the adjacent, which is 485. So to get there, I'm going to do 485. I should have written this in the last time as well. Tan 63 gives me the opposite. So what does the opposite equal, Ben?
951.87.
Sounds good to me. Look at that, 951 points. I've got 0.8, yeah? So 951 being the key fact here, and then that'd be 0.9 to one decimal place. And then, how am I going to work out the distance between the two boats? Take them away. We know all of this is 951. We're not interested in this first bit. So distance between boats, say distance between, is equal to 951.9 take away 557.9. Okay, so I'll put that into my calculator. I'm not going to try and risk trying to do anything like that off the top of my head. 394,
Yeah.
give or take.
Yeah.
There'll always be, like, in any paper, if I looked at the mark scheme, it will always, if I said to one decimal place, I need to say 0.0, just point for myself. They'll always give you a range of values that they'll accept because of rounding and stuff like that, okay?